8-2, multiplying and factoring. So our objective for this section is to multiply a monomial by a polynomial, and then to factor a monomial from a polynomial. And our essential understanding is that we can use the distributive property to multiply a monomial by a polynomial. Okay, so to start, let's consider the product 2x and 3x plus 1. So the way the distributive property is going to work is I'm going to take this thing in the front and I'm going to multiply it by both of the things inside the parentheses. Okay, so 2x times 3x plus 1 becomes 2x times 3x, and then 2x times 1 to give me 6x squared, right? The x times the x gives me x squared plus 2x. And you can see that in this diagram right here, we have 2x up and down, right? An x and an x. And then we have 3 x's plus a 1 on the top row. And as we multiply x times x, we get x squared there, there. And then 1 times x gives me x. So you can see if I count all these, I have 6x squared and 2x, just like I have in my distributive. Easier to just multiply than to draw a big drawing like this, but I think the drawing helps to visualize exactly what's going on when we're multiplying one polynomial by another. Let's try a problem. What is the simpler form of negative, let's write this down here, negative x to the third times 9x to the fourth minus 2x to the third plus 7. So what we want to do is we want to take this negative x to the third and I want to multiply it to everything inside of the parentheses. Numbers first, negative 1 times a positive 9 is a negative 9. X to the third times x to the fourth, remember add the exponents together to give me x to the 7th. Then negative times a negative turns to a positive x to the 6th. Negative times a positive gives me a minus 7x to the third. It is in standard form, negative, that should be a 2, right there, negative x to the third times negative 2x to the third gives me a positive 2x to the 6th, sorry about that, and my answer is D. Let's try the got it problem. Distribute. Multiply the 5n times all three things inside the parentheses. So that's 15n to the fourth minus 5n to the third plus 40n. Okay. And what we've done now is we've distributed this term to all three of these. When we talk about factoring, to factor a polynomial, now this is going to reverse the multiplication process. When factoring a monomial from a polynomial, the first step is to find the greatest common factor, or the GCF, of the polynomial's terms. So, to find the GCF, we are going to find the greatest common factor of all three of these terms. Now, let's break down exactly how this works, and then we'll look at a couple of shortcuts. First term, 5x to the third. Okay, I'm going to split this into its prime factors. Well, 5 is prime. The prime factors of x to the third are x times x times x. So 5 times x times x times x is 5x to the third. Those are all the prime factors that make up 5x to the third. To give me 25x squared, well, anybody remember this? Little factor tree, right? 5 times 5. So that's 5 times 5 times x times x. And for 45, right, that's 5 times 9. And 9 breaks down into 3 times 3. So the prime factors of 45 are 5 times 3 times 3 times x. Okay, so to find the GCF, it's going to be the greatest common factors. So look, they all have a 5. Well, this has another 5, but the others don't. Okay, so that's out. These have 3's, but the others don't. This has 1x. Oh, that's common. They all have an x. But this one doesn't have another one, so the GCF of this expression is just 5x. Okay. Some shortcuts for this is we look for the numbers. We look for the biggest number that divides into all 3 terms, and that's 5. Okay, hint, that's prime, so it has to be divisible by 5. For variables, we take the smallest degree of any common variable, right? So this bottom term just has 1x. That is the greatest x that we can have in our expression. So numbers, biggest number that divides into everything. Variables, smallest degree. Biggest number that goes into all 3 of those. Well, 3 is prime. Does 3 go into all of them? Yep. So my GCF is going to be 3. The smallest degree is the x right there. So the GCF of this expression is going to be 3x. Now, the point of this is that once you find the GCF of a polynomial's terms, we can factor it out of the polynomial. Okay? We can divide it out. What is the factored form of 4x to the 5th minus 24x to the 3rd plus 8x? First, let's find the GCF. Okay, well, the biggest number that goes into all of these, well, this happens to be the smallest number, right, 4. So does 4 go into 24 and 8? Yes. So that's part of my expression. And the smallest exponent is x. So the GCF is 4x. So now what I'm going to do is I'm going to take that and I'm going to put it on the outside of some parentheses. And now I'm going to divide each term by the GCF. So 4x to the 5th divided by 4x would give me x to the 4th minus 6x squared, right? Negative 24 divided by 4 is negative 6. X to the 3rd divided by x is x squared plus 2. And you can see that if I were to multiply this back, I would get my original expression. And that's how you can check when you want to when you're factoring. Right? So you can always check your factored form to see if it's correct by multiplying it back out and see if you get your original expression. Let's try Gaussian problems. Okay. First, GCF. The GCF of 9x to the 6th plus 15. So now this one's a little bit trickier because 9 does not go into all of these, okay? But 3 does, and 3 happens to be the biggest number that goes into all of these. Only factors of 9 are 3 and 3. So 9 either goes into this, 3 goes into this, or it doesn't have a number that is a common factor. So it's going to be 3, and the smallest exponent is x squared. So the GCF is 3x squared. Okay? Let's divide it out. Let's see what's going to be left over. Well, there's going to be a 3 because 3 times 3 is 9. And there's going to be an x to the 4th because x squared times x to the 4th is x to the 6th plus 5x squared plus 4. and no variable there because 3x squared times 4 is 12x squared. What is negative 6x to the fourth minus 18x to the third minus 12x squared written as the product of a polynomial with positive coefficients and a monomial? Well, they all have a negative in the front, so it doesn't say the monomial in the front has to be negative, so I can just factor out a negative number, a negative 6, and of course x squared. Now that would give me a positive x squared plus 3x plus 2. And you can see that if I were to distribute this back, if I were to multiply the negative 6x squared times these three terms, I would get my original expression back again. Let's try a word problem. So a helicopter landing pad, or helipad, is sometimes marked with a circle inside of a square. So that is visible from the air. What's the area of the shaded region in the helipad on the right? And write your answer in factored form. Well, to find the area of this shaded region, the orange part, we want the area of the circle minus the area of the square. Okay, well, we can do this. So, sorry, other way around. Not the bigger one, area of the square minus the area of the circle, right? The square is bigger than the circle, so we find the area of the square minus the area of the circle. So, area of the square, little a sub s. Formula for area of a square is the side of the square squared. So this is going to be 2x squared, or, right, length times width, 2x times 2x. Square, we know that all the sides are the same. They're all equal to each other. 2x squared, when I square it, remember I have to square both things inside the parentheses, gives me 4x squared. Okay. Area of the circle, a sub c. To find area of a circle, need to remember the formula for area of a circle, which is pi r squared. Luckily, I know the radius. Pi x squared, which I can just leave as an expression pi x squared. Okay. Now let's put it back into my original formula. We take the area of the square minus the area of the circle. Doesn't say to solve it because I don't actually know the value of x, but it does say write your answer in a factored form. So I have to factor out the GCF. And notice that they both have an x squared in common. So I can factor that out, and I'm left with 4 minus pi. And that's it. That's my expression. Right? We're not trying to solve it. We're just trying to write my expression for this particular figure. Okay? For my got it problem, suppose the side length of the square is 6x, and the radius of the circle, bad circle, is 3x. Okay. What's the factor form of the area of the circle? So same thing, area of the square is going to be 6x squared, which is 36x squared. Remember, I have to square both of them. The area of the circle is pi times that squared, the radius, which is pi times 9x squared. So usually when we have an expression like this, we write the number first, then the irrational number, and the variable last. Big one minus small one gives me 36x squared minus 9 pi x squared. And in factored form, I got to ask myself, can I factor out a number here too? And I can factor out a variable. So I can factor out 9x squared. So that would be left with 4 minus pi. Does that work out? 36x squared minus 9 pi x squared. So yes. So what is the simpler form of the first expression? We're just going to distribute both of those, and we have 12x to the fourth, and then 42x squared. GCF here, greatest common factor. Well, 4 is not common to both of them, but 2 is, so that's 2a squared. Okay. So factor each polynomial. What do they have in common? They have a 3, they have an m. What's left over? 2m minus 5. Here, 4, 8, 12. They all have a 4 in common. X to the third, x squared x in common. And we're left with x squared plus 2x plus 3. Match each pair of monomials with its GCF. Well, 14 and 35, they both have a 7 in common and an n squared in common. 21 and 18, they have a 3n squared in common. Now this is an interesting one here too. Those have nothing in common, right? 7 is prime, doesn't go into 9. 9's factors are 1 and 9, 3 and 3. Neither of those go into 7. So when two numbers have nothing in common, the greatest common factor is 1. Write a binomial with 9x squared as the GCF of its terms. You can be creative here. As long as 9x squared is divisible by both terms. So we can go 27x to the third plus, let's just do 18x squared. Okay. I don't want to put anything, one of these two variables, it doesn't matter which one, but one of these two variables has to be x squared. Or else, if it was bigger or smaller, then this variable would